Imagine a world where ice burns. Gliese 436b is a planet made mostly of water, but it's so close to its star that surface temperatures reach over 400 degrees Celsius. So why doesn't it melt? The planet's immense pressure squeezes water into a strange state called hot ice, solid even while it burns. A frozen world on fire, proof that the universe plays by its own rules. Deep in the cosmos lies a place called the Boötes Void, a region so massive and empty, scientists call it the Great Nothing. It's nearly 330 million light-years across, yet contains almost no galaxies at all. If the Milky Way were inside it, we wouldn't have discovered another galaxy for billions of years. No one knows exactly why it's so empty, a cosmic mystery that challenges how the universe formed. Imagine a spacecraft that sails on sunlight. No fuel, no engines, just pure light pushing it through space. Solar sails use massive reflective sheets that catch photons from the sun. Each tiny impact gives a gentle push. Over time, that push adds up, accelerating the craft endlessly through the cosmos. It's not science fiction. NASA and JAXA have already tested it. The next generation of explorers might ride on sunlight itself. What happens when time itself runs out? Physicists call it heat death, the moment the universe reaches total stillness. Every star burns out, every atom spreads too thin to touch another. No energy left to flow, no motion, no change, no time. It won't end in fire or chaos, but in silence. A universe frozen forever at the edge of time. Meet HD 189733b, a planet where storms never end. Its skies are deep electric blue, but not from oceans, from deadly silicate clouds that rain molten glass sideways at 8,000 kilometers per hour. Lightning flashes across the horizon non-stop, turning the night side into a strobe of chaos. No calm, no silence, just eternal winds screaming through a world built on storms. When galaxies collide, they don't crash like cars. They flow together like waves. Massive clouds of gas and dust ripple across space, triggering the birth of millions of new stars. These shock waves stretch for millions of light years, a true cosmic tsunami reshaping everything in its path. From chaos comes creation, the universe rebuilding itself, one collision at a time. What if the moon suddenly vanished? Our nights would go completely dark. But that's just the beginning. Without the moon's gravity, Earth's tides would nearly disappear, ocean life would collapse, and our planet's tilt would start to wobble. That means chaotic seasons, massive storms, and climate swings that could last for centuries. The moon doesn't just light our sky, it keeps our world in balance. A frozen world, orbiting a faint star 20,000 light-years away. Astronomers call it OGLE 2006 BLG 390LB, but it's better known as the real Hoth. Temperatures here drop below -220 degrees Celsius. No sunlight, no oceans, just an endless ice desert stretching into the dark. Star Wars imagined it first, but the universe built it for real. Meet Triton, Neptune's largest moon, and one of the strangest worlds in our solar system. It orbits backwards, opposite Neptune's spin, something no other large moon does. Scientists think Triton was once a dwarf planet, captured by Neptune's gravity long ago. Its icy surface still erupts with nitrogen geysers, even in the cold of deep space. And one day, gravity will tear it apart, turning Triton into a new ring around Neptune. In 2008, astronomers spotted a new planet orbiting a young star. They named it Fomalhaut b, a massive world glowing faintly in the dark. But when telescopes looked again a few years later, it was gone. No orbit, no trace, nothing. Now scientists think it might never have been a planet at all, just a colossal dust cloud from a cosmic collision. a world that existed only for a moment and then vanished forever. The first city on Mars won't look like New York or Tokyo. It'll be built under glass domes, protected from radiation, storms, and freezing nights. Power from solar fields, water from melted ice, oxygen made from the red dust itself. AI and robotics will build what humans can't. And when the first sunrise shines through those domes, it'll mark the beginning of humanity's second home. In the vast darkness of space, even death isn't the end. When massive stars collapse, they leave behind twisted remains, neutron stars, pulsars, and magnetars, corpses of suns that still pulse with radiation and scream across the cosmos. Some spin hundreds of times a second, flashing like cosmic beacons. Others warp space itself with their magnetic fury. These are the ghosts of the universe, stars that refuse to die. Somewhere out there could be a world made of mirrors. A planet so perfectly reflective that it doesn't just shine, it watches. Its oceans reflect the stars. Its clouds echo galaxies, and its light bends like eyes following your gaze. If you looked at it through a telescope, you wouldn't just see it. You'd see yourself, staring back. Not everything that shines wants to be seen. What if a star could scream? Deep in space, some neutron stars spin so fast and send such intense radio bursts that when we convert them into sound, they howl. These are pulsars, collapsed stars with magnetic fields billions of times stronger than Earth's. Each rotation sends a pulse of energy like a heartbeat echoing through the void. The louder they scream, the faster they die, fading into silence. What if the Earth suddenly stopped spinning? Everything not anchored to bedrock would be thrown eastward at over 1,600 kilometers per hour. Oceans would surge across continents, flattening coastlines in minutes. The sky would fill with dust and fire as cities and forests burned from friction and debris. Half the planet would face endless day, the other eternal night. Life as we know it would end, all because our world stopped moving. The sun isn't yellow, it's white. From space, without Earth's atmosphere, sunlight shines pure and bright, blending all colors equally. Our sky scatters blue light, leaving the sun looking golden from the ground. In truth, it burns with every color at once, a perfect white star. So the next time you draw a yellow sun, you're seeing Earth's filter, not reality. Not every moon was born where it orbits. Some were stolen. When a planet's gravity catches a wandering rock or passing asteroid, it can trap it forever in orbit, a cosmic theft. Our own moon might have formed differently, but around the solar system, many moons are captured strangers. Gravitational theft, proof that even in space, possession is a matter of pull. Astronomers just caught a black hole merger that shouldn't exist. Two huge black holes crashed together and forged a new one about 225 times the mass of our sun. Here's the twist. The original black holes were so massive they fall in the forbidden mass gap, where stars shouldn't leave black holes at all. How do you get them? Likely from earlier black holes merging again and again inside dense star clusters. A cosmic rule broken, and the universe rewriting the script in real time. A Dyson swarm isn't science fiction. It's a real plan for the future. Instead of one giant shell around the sun, scientists imagine billions of solar satellites orbiting in formation, each collecting power and sending it back to Earth. It's humanity's first step toward harnessing the energy of a star. The blueprint for becoming a true spacefaring civilization. What if life didn't need carbon at all? Some scientists think there could be planets where DNA-like molecules evolved under completely different chemistry, using silicon, arsenic, or even ammonia instead of water. These worlds might look nothing like Earth, yet still host complex alien biochemistry. It's a reminder that the building blocks of life might be far more flexible than we imagine, and somewhere out there, life could truly be alien. Charon isn't just Pluto's moon. It's nearly half its size, making them more like twins than planet and satellite. Instead of one orbiting the other, they both circle a point in space between them, a true binary system. Charon's surface is scarred by ancient canyons and tinted red by frozen gases escaping Pluto. Together, they form a cosmic dance unlike anything else in our solar system. Billions of years ago, Venus may have been covered in oceans, calm blue waters under a gentle sky. But as the sun grew hotter, the planet's atmosphere thickened, trapping heat in a runaway greenhouse effect. Those oceans boiled into steam, and the surface turned into a furnace of crushing pressure and acid clouds. Today, Venus shines like a jewel in the sky, a reminder of a paradise that destroyed itself. Building a space elevator on Earth is nearly impossible. Our gravity and atmosphere make the cable materials break under their own weight. But on Mars, it could actually work. The planet's weaker gravity and thin air mean a tether made from advanced carbon composites could stretch from orbit down to the surface. Cargo could glide up and down without rockets, cutting launch costs to almost nothing. It's not science fiction. It's the first real step toward turning Mars into a second home. In a universe filled with fire and fusion, there's one place colder than anywhere else, the Boomerang Nebula. It's just 1 degree above absolute zero, colder than the faint background temperature of space itself. Astronomers believe it's a dying star expelling gas so fast it chills itself beyond cosmic limits. Light takes 5,000 years to reach us, frozen in time. A glimpse of the universe's coldest breath. Imagine a world made almost entirely of metal, dense, glowing, and forged in cosmic fire. Astronomers discovered such a planet called PSRJ 1719-1438b, orbiting a dead neutron star. It's believed to be the leftover core of a massive star stripped down to pure crystalline carbon and iron, heavier than anything we could stand on. A teaspoon of its material could weigh tons. It's the galaxy's natural metal world, a real-life planet of steel and diamond. Light travels at 300,000 kilometers per second, the ultimate cosmic speed limit. But even light can't outrun the expansion of space itself. Galaxies at the edge of the observable universe are moving away from us faster than light, not by breaking physics, but because the very fabric of space is stretching between us. It's the universe itself that's speeding beyond reach, a cosmic race where space wins every time. Imagine a planet so extreme it could power itself. A world hot enough to fuse hydrogen in its core like a miniature star. Astronomers call them failed stars or brown dwarfs, objects caught between planet and star, massive enough to glow with internal heat but not quite ignite full fusion. In theory, if a planet grew just a bit larger, it could generate endless energy on its own. A natural reactor, burning forever, the line between a planet and a sun. Saturn may be famous for its rings, but one of its moons decided to copy it. Scientists discovered that Rhea, Saturn's second largest moon, may have its own faint ring system made of icy debris. These rings likely formed from collisions with small meteoroids, leaving a frozen halo orbiting the moon. It's the only known moon in our solar system that might have rings, a miniature Saturn hiding in plain sight. Beyond Neptune, something is tugging on the orbits of distant icy worlds, as if a massive unseen planet is pulling from the dark. Astronomers call it Planet 9, a hypothetical giant hidden in the outer reaches of our solar system. It could be 10 times Earth's mass, orbiting so far away it takes thousands of years to circle the sun. We haven't seen it yet, but its gravitational fingerprints are everywhere. Somewhere out there, a lost world may still be waiting. High above Earth, a new gold rush is forming. Not in mountains, but in the void. Metallic asteroids rich in gold, platinum, and nickel may hold trillions in value. Companies and space agencies are exploring robot miners, space refineries, and orbital supply chains. Yet the dream faces giant hurdles: cost, distance, and the laws of space. The real treasure may not be gold on Earth, but the resources that let humanity build in space. In a universe racing towards stillness, there may come a moment when the last particle of light is emitted. Photons appear to have infinite lifetime under known physics. They don't decay. But as the cosmos expands and cools, even light loses power to change anything. Over unimaginably long timescales, star formation ends, black holes evaporate, and all that remains is quiet photons drifting through near-empty space, the ultimate last light in a dying cosmos. While we cannot know exactly which photon will be the last, the idea captures the profound endpoint of a universe stretched into infinity. Out in the cold depths of space lies a planet where the air doesn't flow and the atmosphere collapses into ice. On some worlds orbiting dim red stars, the night side becomes so frigid that gases freeze onto the surface. Certain exoplanets around flaring red dwarfs may have their atmospheres collapse entirely into solid ice on the dark side. These frozen hells show how planets can turn from fiery furnaces to icy tombs. Extremes of temperature, where day and night become worlds apart and life must face a frozen vacuum. Though we haven't observed one freezing entirely into solid gas, the physics tells us it's possible. The real universe doesn't always behave like Earth rules. In 1859, the sky turned green. Across the world, people saw glowing curtains of light reaching as far as the Caribbean. Telegraph wires sparked with fire, even when disconnected. It was the Carrington event, the strongest solar storm in recorded history. A massive burst of plasma from the sun slammed into Earth's magnetic field, creating auroras unlike anything seen before. If the same event happened today, it could knock out satellites, power grids, and global communications within hours. The night the sky glowed green was a warning. The sun can remind us who's in charge. Imagine a world that breathes, a planet whose atmosphere expands and contracts like lungs. Scientists have found exoplanets with atmospheres that pulse in rhythm with their stars. As radiation rises, gases heat up and swell outward. When it falls, they cool and collapse back. These atmospheric waves create a slow planetary heartbeat visible from light years away. On some of these worlds, temperature swings can reach hundreds of degrees, each breath a struggle for balance in an endless cosmic rhythm. Phobos, Mars's largest moon, is living on borrowed time. Every century, it spirals closer to the red planet, just a few centimeters at a time. In roughly 30 to 50 million years, it'll either crash into Mars or be torn apart by its gravity, forming a shimmering ring in the Martian sky. Craters, cracks, and grooves already mark its surface, evidence of the tidal forces pulling it apart. A slow-motion cosmic tragedy, orbit by orbit. There's something massive out there, and it's pulling our entire galaxy toward it. Astronomers call it the Great Attractor, a mysterious region of space with such intense gravity that it's dragging the Milky Way, along with thousands of other galaxies, toward its hidden core. The problem? It lies behind the Milky Way's dense center, shrouded in dust and stars. We can't see it directly, only feel its pull. Whatever lurks there is bending the flow of the universe itself. Another interstellar visitor just slipped through our solar system. In July 2025, astronomers in Chile spotted a faint object moving far too fast to belong to our solar system. They confirmed it was 3I/Atlas, only the third interstellar object we've ever seen. Through early October, it passed near Mars's orbital distance and headed toward the Sun, reaching perihelion around October 30th at roughly 1.4 astronomical units. Perihelion is the moment a comet gets closest to the Sun, the point where it heats up and changes the most. But when it emerged from behind the Sun, something was off. Its bright tail had almost completely vanished. Some people blamed aliens, but astronomers say it was likely just geometry, the tail pointing almost directly away from Earth, or a temporary drop in activity as the comet heated up. What we do know is that 3I/Atlas dimmed after perihelion, and its appearance shifted in ways scientists are still studying. Now, racing through space at more than 65 kilometers per second, it's already heading back into interstellar darkness forever, leaving behind one more clue about how comets form around other stars. Far beyond the planets, past Pluto and the Kuiper Belt, lies a region we've never seen, the Oort cloud. It's a massive spherical shell of icy objects surrounding our solar system, stretching nearly halfway to the next star. Most comets we see come from this frozen frontier, leftovers from the dawn of our solar system. It's so distant that sunlight there is just a faint whisper, and a single orbit could take millions of years. The Oort cloud marks the true edge of the sun's influence, the invisible border where interstellar space begins. It's the solar system's final frontier, and humanity has never even seen it. What if every black hole wasn't an end, but a beginning? Instead of destroying everything it swallows, imagine if it sent that matter somewhere else, across the universe, or even into another one entirely. A black hole's core, called the singularity, crushes matter to an infinite density. But some theories suggest there's more, a hidden exit called a white hole, where everything that falls in could be expelled back out. If true, every black hole could be part of a vast cosmic network. Wormholes linking galaxies or dimensions we've never seen. We might be surrounded by gateways disguised as monsters, and somewhere, maybe something is falling out of one right now. Imagine a rocket that never runs out of fuel. Instead of burning propellant, it uses quantum tunneling, the strange ability of particles to slip through barriers that should be impossible to cross. In theory, this quantum rocket could thrust forward by shifting momentum through vacuum fluctuations. The invisible jitter of quantum space itself, it wouldn't break physics, but it would stretch it to the limit. If perfected, it could mean infinite exploration. Spacecraft powered not by fuel, but by the very fabric of reality. Far beyond Neptune, the dwarf planet Haumea spins so fast it's stretched into an elongated egg-like world. It completes one rotation in about 3.9 to 4 hours, making it one of the fastest spinning large bodies in the solar system. That rapid spin helps explain its odd shape, and in 2017, astronomers even found a narrow ring circling its equator. Haumea also has two small moons, Hi'iaka and Namaka, likely born from ancient impact debris. Its bright surface shows crystalline water ice, glittering like frost in deep space. Discovered in 2004, Haumea proves our outer solar system still hides worlds that break the rules. In 2016, astronomers found a ghostly galaxy in the Coma Cluster, called Dragonfly 44. It's almost the size of the Milky Way, but nearly invisible. Only a tiny fraction of its mass glows. The rest is dark matter. So dark, it holds together through gravity alone, with just a few 100 million stars instead of hundreds of billions. At first, scientists thought it might be 99% dark matter, a cosmic shadow of a normal galaxy. Later studies suggested it might hold less dark matter than we thought, but it remains a mystery. How does a galaxy this big exist without light? Dragonfly 44 is a reminder that most of the universe is still hiding in the dark. NASA is planning something even farther than Voyager. It's called the Interstellar Probe, a mission designed to leave the solar system entirely, on purpose. If approved, it could launch in the 2030s, traveling over twice as fast as Voyager 1, heading toward the edge of the heliosphere, the bubble carved by the sun's wind. Once outside, it would study the true conditions of interstellar space, where the sun's influence ends. Unlike Voyager, this probe wouldn't rely on luck or fading instruments. It would be built to explore the unknown frontier beyond our star's reach. A message from humanity, finally crossing into the galaxy itself. What if reality isn't real? The simulation hypothesis suggests the universe itself could be an advanced digital simulation, a kind of cosmic computer program. Philosopher Nick Bostrom first proposed it seriously in 2003, arguing that if future civilizations can run ultra-realistic simulations of consciousness, they probably already are. And we might be inside one. From quantum physics to cosmic patterns. Even scientists like Neil deGrasse Tyson and Elon Musk admit the odds could favor simulation over reality. Maybe the code of the cosmos isn't written in atoms, but in algorithms. About 49 light-years away, scientists have found a planet that might be one of the best places for alien oceans. LHS 1140b. It's roughly 1.5 times Earth's size, orbiting a cool red dwarf in its habitable zone. Recent studies suggest it could be covered by a global ocean, or perhaps a thick layer of ice floating above deep water. Unlike many exoplanets, this one's atmosphere might actually be stable, meaning liquid water could exist at the surface. If confirmed, LHS 1140b could be our first real look at a habitable ocean world beyond Earth, a cosmic mirror of what our planet might look like from light years away. Deep within the sun's atmosphere, invisible magnetic fields twist, tangle, and suddenly snap. When these lines of force reconnect, they unleash massive bursts of energy, enough to power solar flares and coronal mass ejections that can light up the skies on Earth. This process, called magnetic reconnection, converts magnetic energy directly into heat and motion. It's nature's own plasma explosion. NASA's satellites have even caught it happening near Earth's magnetosphere, proving it's not just a solar event, but a universal cosmic trigger. From the smallest spark in our sun's corona to the biggest storms in space, reconnection is the hidden heartbeat of the universe's most explosive moments. NASA just captured images of a space rock that defies physics, an asteroid called 2025 OW spinning faster than any we've ever seen. It's only a few hundred meters wide, but completes a full rotation every 15 seconds. So fast that it should have torn itself apart. Scientists think it might be made of solid metal or fused rock, giving it the strength to survive such impossible speeds. Studying objects like this helps us understand how asteroids form, hold together, and sometimes even threaten Earth. 2025 OW isn't dangerous, but it's a glimpse into the wild physics of small bodies hurtling through our solar system at breakneck speed. What if the universe's fundamental constants changed by just 1%? It sounds tiny, but it would completely rewrite reality. Atoms would stop behaving the same. Electrons might crash into their nuclei or drift away, making matter itself unstable. Metals could shatter like glass. Air might liquefy, even water could vanish or freeze solid depending on the shift. Stars could explode or go dark overnight because fusion depends on perfectly tuned forces. Gravity might strengthen or weaken. You could feel heavier, buildings could warp, and planets might drift from orbit. Electronics Wi-Fi and atomic clocks would instantly fail as the speed of light and electromagnetic forces change, and life? DNA would unravel, cells would stop working, and oxygen wouldn't bind to blood. All it takes is a 1% tweak, and the universe collapses into something unrecognizable. A reminder of how fragile and how perfectly balanced our reality really is. On Earth, plants know exactly which way to grow. Roots go down, stems go up. But in space, gravity's gone, and everything changes. In zero-G, plants can't sense up or down. Their roots grow in random directions, leaves twist unpredictably, and even photosynthesis slows down because light hits cells differently. Yet somehow, life adapts. Astronauts on the ISS have grown lettuce, zinnias, even chili peppers, teaching us how to engineer life beyond Earth. These strange, weightless gardens show that biology can evolve anywhere, and that someday we might harvest entire crops under alien skies. Saturn's moon Hyperion looks like a giant frozen sponge, but its behavior is even stranger. Instead of spinning normally, it tumbles unpredictably through space, wobbling in every direction. Its surface is filled with deep, sharp-edged craters that make it look hollow, and scientists think it's so porous that it's basically a cosmic pumice stone. Because it barely holds itself together, even small impacts can carve huge pits. Hyperion is one of the most chaotic objects in the solar system. A drifting, tumbling sponge world that refuses to behave like any other moon.